Hello, my name is Aimilios Vourliotakis, and today I'm going to talk about validation of equality entity relations in linked data, which is what the prototype is about. But of course, this is a description of the bigger picture of what we're trying to do. So here goes the summary of what I'm going to talk about. I'm going to provide an introduction. I'm also going to provide a linked data overview for those that are not comfortable with linked data. It's not going to take long, I promise. And I'm also going to give out our proposed methodology for validating equality relations in linked data. And at the end, I'm going to give out a few points about next steps in our research. So, as an introduction, I'm going to start bluntly by saying what we propose. We propose a method for detecting and resolving erroneous equality relations between entities in linked data through a combination of similarity techniques, computing similarity between the two entities at different levels, a different scope, plus through the use of granular properties that provide supportive argumentation about the outcome of the similarity techniques. But first of all, when I'm talking about equality relations and linked data, what it is exactly. So, what is linked data? Linked data is basically a number of proposed technologies for publishing structured or varying levels of structured data on the web so that it can be interlinked and in essence used by machines. Here you can see the linked open data cloud, which is the predominant example of linked data, which is quite huge, as you can see. So in this picture, you have, of course, a number of nodes and a number of links between them. So what are these nodes, these data sets that exist within its data? So the basic component is RDF, which basically states that all things, entities, and their relationships can be described in triples, subject, object, and predicate, so that, for instance, Asimov is the author of the last question essay, or what it was exactly. These things are described by unique identifiers called IRIs or URIs. IRIs is the correct notion. And from then on, the other layers are suggested, not enforced on dataset authors. That is, you have different languages like RDFS and all that enable you to have more rich semantic expressivity in your dataset. Like class hierarchies, like cardinalities and functionality of properties and that sort of things. You also have predefined namespaces that give you list of predicates to use, or you're free to use your own when you create your dataset. And the interlinking part, that is the connection between the datasets, is done through predicates with same as being the most commonly used one, which its definition is basically that two entities refer to the same real-world entity. So this has led to a problem, at least according to what it's been discussed in the linked data and the semantic web field. That is because, first of all, the nature of linked data, the nature of the web of data, if you want, is decentralized in the way it is created and in the way it is interlinked. You have different level of analysis or naming conventions or update frequencies imposed on the different data sets that are linked. And of course, when an author creates its dataset, his or her dataset, sorry, he has different implicit contextual circumstances in his mind, or her mind. So when the interlinking part comes, sometimes you're not connecting two entities that are referring to the same real-world entity, but two entities that are similar or even related. So, of course, this leads to erroneous equality assertions about entities. And now, hopefully, after all that, our initial problem definition, that is a method for detecting and resolving erroneous equality relations between entities and linked data, makes more sense. So, moving on to the relevance to other work, I have to say that the general problem of what I'm talking about is definitely not new. Record linkage, which is kindly connected to what I'm talking about, is older than most people in this room. It was introduced in 1969. And of course, it was about datasets, which is quite different. And that's the thing. The general problem has also different names, like entity coreference, named entity disambiguation, entity resolution. But the thing is that all these things are different variations of connecting to or disambiguating between two entities and understanding whether they are the same or different. Especially in the domain of linked data, this is quite new because linked data is quite new itself. And our thought is that it is crucial, this problem in relation to linked data, because linked data, in order to use linked data in commercial applications, you need it to be reliable. And according to the problems we discussed before about the nature of knowledge within linked data, you have a lot of noise because of what we discussed before. So there have been previous attempts in the field of linked data, but most of them relied on human experts too much, at least that's what our thought is, and they end up being too domain specific. The proposed methods basically are not generic enough to be used. In our view, what we're interested in doing is creating a more domain-independent method that rely as little as possible on human experts. I'm not going to say at all, because I don't believe that's the case. That's my point of view. So this is the overall architecture of the system. Our overall aim, as we said before, is validation of asserted equality relations using a combination of similarity estimators aimed at different scope, and by providing a supportive argument about the validation output through the granularity estimator component. So, what is the similarity estimators component about? So what we propose is 3 naive implementations, that is for a first prototype at least. The first one is a syntactic estimator, which uses Yarrow-Winkler string comparison. Now, Yarrow-Winkler has many different versions, starting from 95, I think, but I think the 2006 one is the latest one. And we can do that, we can use that string similarity estimator for names, for comparing strings. Of course, we need to be careful because Yarrow-Winkler, as most string similarity estimators, only work with names and not, for instance, with full names that contain 2 different first names and surnames, or with addresses, or with every string in general. At the second layer, we have a structural similarity estimator, which basically takes graph isomorphism between relevant subgraphs created from RDF triples around its entity. That is, starting from its entity of the 2 that we're going to compare, we're creating subgraphs that basically provide us a contextual definition for its entity, and we do graph isomorphisms over that subgraphs. For our third layer, inspired from social networks basically, and from the notion of homophily, which is people with similar characteristics are more connected, we created our own version, which is entities with shared and equal connections are more similar. So in the end, overall similarity will be calculated as a probability distribution over the proposed estimators. For a granularity estimator, our notion was that although linked datasets are not databases, you do not have primary keys, you have the notion of predicates or properties being distinguishing. That is, its property can be, as its property has more unique values over the total number of occurrences, it can potentially be a granular property, or a property that basically distinguishes between entities. Of course, we have to take overall presence of the predicate in the data, because as we said before, knowledge within linked data can be incomplete. So this granular property can provide the supportive argumentation we need for the invalidation of an asserted equality relation and be used in conjunction with the similarity estimators I talked about before. Now, there are a couple of open issues about this proposed prototype. That is, if normalization is going to be done, it has to be non-pervasive, because data can be sensitive to pervasive normalization techniques. How the collection and the analysis of the granular predicates is going to be handled. And as mentioned by my reviewer in my paper, who I thank, the notion of creating property sets as granular as identifying or distinguishing sets of properties instead of using individual properties. That is also something that needs to be thought of. So for the evaluation, and I'm quickly going to go through this because I've exceeded my time, we have two outputs. One is quantitative, and the supportive argumentation part is qualitative. So the overall evaluation will require both things to be evaluated independently. And finally, for our next steps, well, I have to say for our first implementation, we're going to use benchmark ontology, which is kind of safe in terms, because it's created for an instance matching technique. But for the future, we're looking into more realistic and commercially interesting scenarios like OpenStreetMap for the same problem. We're also looking at redefining similarity estimators with respect to generalizations, because as I said before, we're looking into naive implementation of all three layers. And for the end, I left the most interesting part, which is for the future, we're looking for a more richer set of relations to check and not just equality relations. That is, for instance, instead of having the same mass link, you could have the adjacent to, or within. Those are predicates contained in OpenStreetMap. What if we discover contradiction in those relations? Are there ways of discovering and resolving the contradictions? So that's the end. Sorry for taking a couple of minutes more. Hopefully you won't have enough questions for me and we can resolve this. Well, I think that even Silk was created by a group which is directly connected with DBpedia, right? I think it was Silk. But in any case, both tools, it's what I said before, both tools require humans in the end, right? They give you hints at finding links between datasets, unless I'm mistaken. Now, that's the thing. Most proposed solutions are too supervised. At least that's what that's my notion. I'm not saying that if you have fully unsupervised techniques, you will be able to reach a certain level of quality. But I think there needs to be a balance. You need to have more generic, but somewhat good methods for either discover links or discovering erroneous links, because these two problems might be the same or might have differences. Well, I get it. It's something that's been haunting me ever since I conceived this, negation of the problem, if you want. But in my view, for instance, think about the use of same as, right? So the use of same as, apart from the various definitions each person that does the interlinking gives to same as, which is always going to be subjective. As I said before, people use same as to refer to similar or related, and that's in violation of yeah, I didn't talk about automatic. I can say that automatic also may contain errors, but the thing is that another thing I can tell you is that in a very conceptual level, two things can be equal according to given implicit contextual circumstances, right? So you can have things that, for instance, in the scenario of a user query, you can use information combined from both things. But in a different scenario, you cannot, because one scenario basically gives you contextual information that the things are the same and can be used in conjunction, the information contained within them, whereas in the other case, you cannot. I'm not saying that they're entirely different. All I'm saying is that there can be differences. That's why I use ontology matching as one of the different ways of mentioning the problem. Sorry.